Alright, anyway, I guess we'll just kind of go through here. This is the voltmeter section for Electude, which goes over the voltmeter itself, but it also goes into some basic voltage principles, which they kind of cover. They don't necessarily do the greatest job in my opinion, but they kind of do. So the first thing you're going to do here is you're going to select your pieces of the meter. So you've got, on this particular setup, a DC and AC voltage switch selector up at the top. So if you click on that, which it's not going to work right now, you switch back and forth. The rotary dial, your current or amperage connection, your voltage and resistance connection, and your common or ground connection. Now when you're dealing with meters, every single one of these I've ever dealt with has had a black ground lead or common lead and a red lead for the rest of the connections. So the black indicates a negative, the red is a positive, much like most of your battery cables. Alright, so when we're setting up this meter, there's a bunch of different things that you've got to play with here. We've got an AC-DC selector switch, so if you click on that, it moves. Now when you're looking at it, the squiggly line indicates voltage that goes up and down or alternating current. So the amps actually move back and forth instead of one direction. And these straight lines, so you've got the straight line over a dashed line, that indicates DC current. There is some AC that you're going to run into in a car, but for the most part you are going to use DC when you're talking about automotive. Now this rotary dial over here, the omega symbol is resistance and the V is voltage. Down here at the bottom, A is amperage or current. So within each scale we've got a bunch of different settings depending on what you're looking for. Some meters have this, some of them simply have a voltage or a resistance, and then you switch your readings with buttons or they auto range. So this one, we're looking to set up battery voltage. Battery voltage in an automotive system, a fully charged battery is 12.6 volts. An operating voltage system, like the car's running, alternators charging, all that stuff, should be 15 volts or less. Usually less. 15 would be on the higher side. Typically you'd be looking at like 14 and a half, or actually some of your newer ones don't even charge all the time. So either way, we've got 200 millivolts as our first setting. That's not going to be enough. 2 volts, which if we're looking for say 15 volts, that's not going to work. Or if this is asking for a battery, so it's just going to be 12.6, 12, 12.6, depending on what they show. 20 is going to do that. 200 will show us that, but it won't be as accurate. And 600, same deal. It will show us 12 volts, but it won't be as accurate. So we want to pick the area that's going to be the most accurate. So that'll be the 20 volt section, because we're going to be just under that. And then the last thing here, the red leads can bounce back and forth depending on where you need to put them to do voltage. And I'm going to talk about that, because if you put this, if you have a real meter and you put this thing in an amperage section, you are going to blow the fuse in the meter. Which, if you have a meter like the Fluke that I have, it's a pretty expensive fuse. I want to say last time I bought one it was like 12 bucks or something. So it's a special slow burn fuse. You can put just a regular like glass fuse in there, I suppose, but the actual proper fuse for the meters are usually pretty expensive. Or sometimes they don't even have a fuse and you hook that up wrong and it fries the meter. So pretty much everything you're going to do with this meter, unless you're checking for amperage, is going to be in this spot here. In fact, don't ever hook a meter up to the amperage unless you are 100% sure what you're doing, because you can damage the meter, especially if it's like a cheaper meter. Some of those won't have a fuse and they just fry them. Okay, so I basically walked you through what to do there. I'm not going to check it. This next one, we are measuring stuff with a voltmeter, but we're also trying to observe voltage in a functional circuit. And I can't click on it yet, but I will be able to. This is the switch for the circuit here. It turns on and off. We can use that to manipulate the circuit. When you go to hook this meter up, I'm not going to hook it up into the right places right now, but I'm just going to hook those. The leads like drag, and they have these little square boxes that they'll latch onto. If you just pull it into the middle and then let go, it goes back to the center area. We would need to set this meter up to measure the battery voltage. Now, the short line, long line, that indicates a battery in a wiring diagram. Actually, that technically shows one cell of a battery, but either way, that's the battery area. So you would hook those leads up in the right place, turn the dial to the correct reading to get the voltage for an automotive type battery, and then you would get that. So again, as always, read these sections. In fact, if you read these things, it will actually tell you where to hook the meter up for the most part. Although this one I don't think it really does. You just have to know that this little area here is the battery in the system. Alright, so I'm not going to show you how to do that. You've got to figure out some of it on your own. Okay, so here's where we get into measuring voltage. So I'm not going to do that one yet either. We'll get to the point where I can do this. So I'm going to go with this R1 is actually a light bulb, and you can see that when you flip the switch on, they light up. You flip it off, they turn off. So I'm going to hook this meter up across the light bulb from 12 to 19. Set the meter to where it reads. And when I turn this switch on, we're going to see how many volts are used across the light bulb. So 11.9. That's almost 12 volts. The battery system is running on a 12 volt system, so that's almost all of it. We can take this thing, put it over at the battery plus, and then we've got 12. So if we hook it up across, this looks like a resistor here. Actually, that's a fuse. I think that would be a fuse in this wiring diagram. So we've got a fuse, we've got a bulb, we got all that stuff. So again, kind of read what you're looking for, and actually it'll tell you where to hook it up. So if we want to measure the voltage across the switch, we can do that too. With the switch on, we are dropping 1/100th of a volt. So 1/100th of a volt is being used across this switch. When we turn it off, what do you think we're going to see here? I'll turn it off in a second here. Just think about that. Come up with what you think this is going to be when I flip the switch off. And when I flip the switch off by clicking on it, we've got 12 volts. And that is because there's a difference in voltage here. So the voltage is not going through the switch. So we have 12 volts on this side of it, and we've got ground on this side. And in the center, we have a disconnect. So we have potential voltage, but it's not flowing. This is kind of one of the bigger things with this unit, is watching like what's going on with the voltage as you turn stuff on and off. Now, I don't know that they do the greatest job of explaining the fact that this goes to 12 when it's open, meaning the circuit's not working, because there is no current flowing, and it goes to this and it goes to the 1/100th of a volt when it's closed, because there's a little bit of volt drop or a little bit of current being used in this switch, but not very much. So here's what I'm trying to get across here, and I'm not sure if I'm doing a great job of it or not. But in order for voltage to be used up, work needs to be done, or there needs to be an absolute absence of work. So like right now, is this a complete circuit? No, because the switch is open. So because it's an incomplete circuit, no voltage can be used. So it shows the potential. You have the potential for 12 volts to flow between these 2 points. So that's the difference in voltage. The difference in voltage between point 2 and point 3 here is 12 volts. So that's the difference. That in this case is because there is no amperage, or there is no electron flow through these points. So you have a difference of 12 volts. Now when we close the switch, it doesn't go to totally zero. So let's go down to the light bulb again, and it doesn't really matter which one we pick. But we've got kind of the same deal here, only it's not. So we still have, there's a major difference in voltage between 14 and 21, but it's not because of the absence of flow now. Now it's because the voltage is being used up. So as the amperage goes through this circuit, it goes through the light bulb, and it takes the voltage pushing it to get through the light bulb. So you're using, this is the difference in voltage between the 2 points again. Okay, so it's not that you are, no. So that's it. That it is the difference in voltage in 2 points. Here it's because it's being used, and when it was across the switch and the switch was open, it was because it couldn't be used. So it's all about where your electrons are used and the difference in voltage as it goes. So what they don't really talk about here is this battery is 12 volts. The voltage is what pushes the electrons. It is the force behind the electrons going through the circuit. Voltage only drops in an operating circuit. Voltage only drops where the work is actually being done. So that's kind of one of the things they're not really showing you. But you're going to follow the directions down here. So we would watch it at 2 and 3 with the meter set up properly. And we would check that, which I'm not going to check. And you would answer these questions based on what's going on there. Alright, then we would move it just to R1, which would be resistance 1. In this case, it would be a light bulb. They want to know what the voltage is there. Again, you're going to have to set the meter up properly to read that. And so connection point 4. So they want you to find the voltage here. So in order to find the voltage there, they don't really tell you what you're going to have to do. But if you're just trying to find voltage at any one spot, you always put the black lead on the negative of the battery. Then you use the positive lead of the meter to find your voltage. Alright? Now when they ask you to measure across something, that is from one side to the other. Okay, so if you're trying to find the voltage across R6, you put the leads of the meter in a way that they measure the voltage being used just across that one point. Alright, so that's kind of a brief overview of this Electude Volt Meter. I think I went a little bit more in depth than what they are, but electricity is like a weird, hard concept to follow. So, there you go.